We got a humdinger of a problem of the day today. Let's see it. It says a chord has a distance of 8 meters from the center of a circle. Some of you are going like, I thought chords were music. And we have a diameter of 34 meters in that circle. We want to find the length of the chord. My goodness, that's a lot going on. Let's read it again. A chord has a distance of 8 meters from the center of the circle, and there's a diameter of 34 meters. Find the length of the chord. A lot of interpretation. Let's take a look at this thing. This may take us a little bit of time, folks, but hey, go ahead and give us some calls, all right? Let's see what we got. We got a circle. That always helps. And this is one definitely you'll want to draw. You'll want to draw a circle out. So at home, if you're following me or at work or wherever you're looking and watching this video, do so, all right? Now, a few little things. We've got information, and information is always good if we know what to do with it. We got an 8 meters, but it's based on a distance. Also, we got the word chord, and a lot of us are going like, not music. Nope, it's spelled the same way, but that's not the idea here. But what a chord is, it's going to be a nice little, good old, how would we like to say, segment. It's a line segment. I was going to get the right word there. I was letting y'all think about it. Now, let's draw a little old line segment right across there. We'll put it horizontally. It's a little bit easier to look at that way. And according to the information, what do we know about that chord? Not a lot. There it is, all right? But we do know this, that is 8 meters from the center of the circle. Well, right there's your center of the circle. We put a little dot there, all right? And what we're going to do is we're going to show you what this distance business is all about. That, my friends, is the distance from here to here. It's a perpendicular. It is a right angle forming there. That helps a lot because those of you who've had geometry, and that's where the tricks are here. This is definitely a geometry question, strong geometry question. You know, one thing that's going on here, this chord is now being cut in half if we have a perpendicular, all right? So it could be a radius, it could be a diameter going to that chord, but as long as it comes perpendicular, that cuts it in half. And folks, that's how we have to have it. Distance is, cutting that distance is the perpendicular, all right? So there's your 8, all right? So we're moving some things. Now, another hint. Got a lot of information. Like I said, just got to know what to do with it. We got 34 meters here. Diameter, not radius, but diameter. So what we need to do is we're going to bring in a radius. Now you say, Ernie, why'd you do that? Well, let's see why I did it. We've created a triangle, not just a triangle, but a right triangle. And we know 8. Well, some of you are saying, was that 8? Nope. Guarantee it's not going to be 8. But this one we do know. It's a radius. It's half of that 34. So let's put a 17 right there. Whew. We've got a setup. We have two sides of a right triangle. If we can do that, we can use our friend the Pythagorean theorem. Now I want to tell you something, a little aside here. All you students who are getting to the Pythagorean theorem, and those of you who are taking geometry and you're taking pre-calculus, trig, and calculus, the Pythagorean theorem never goes away. These right triangles are so important. And on the ACT, you can improve your score quite a bit if you spot a lot of right triangle relationships happening based on certain rules that you've been given, especially in geometry. And even just in good old algebra settings, all right? So let's go ahead and figure this one out. Let's put an X right up there. And we can start looking. Now, some of you all who are really good at this geometry stuff have seen this a few times. You know, we'll use a triple because actually that is going to be an integral value. That means it's going to be an integer, all right? No fractions, no roots, no strange things, all right? But let's figure it out. Let's go ahead and use the Pythagorean theorem. Right, here we go. X squared. That's right there, plus 8 squared, because folks, remember, we want to do square the legs, add them together, and that equals the hypotenuse squared. So going back to the infamous, some of you are like, Pythagorean theorem, I'm not sure what that is. It's that a squared plus b squared equals c squared business, all right? A and b are the legs, which means the right angles form there. Sometimes we're always used to seeing it in a different position. This one's shooting out and to the right, okay? Shooting up and to the right there, all right? And how about it? Put a 17 squared over here. Now this is where it's nice to know those perfect squares, my friends. This is really where it helps out a lot. We've got x squared plus 64. Over here I've got 17 squared, which is going to pile up and give me 289. All of a sudden things look a little bit easier. you've got your numbers there. Let's do something with them. We want to get x by itself. That's the whole game when we're trying to figure out what the value of a variable is to get it isolated, get it by itself. So how about it? Let's subtract that 64 off. And we've got an x squared right there. On the right-hand side, I get a 225 because that's what happens when you subtract 64 from 289. And the answer's not 225. Some of you are going, oh, we're done. Not yet. We've got to square root both sides. And this is another reason why I like for my students to know, and you guys out there too, if you're working problems of this fashion, it's nice to know those perfect squares because we have one. 225 will break down into an exact number times itself. And it doesn't have a root involved with it either, okay? It's a nice integer value. And that x is going to be equal to 15. All right, because that's what the square root of 225 gives us. 15 times 15, 225. So, Ernie, how'd you know that? Someone made me memorize a few of those things along the way. That's a key. That's a key. I can also go hit the calculator, I know, and write square root 225, and you'll get, wow, it's there. And that's good. That's good. All right. Now, let's go back to the problem. It says a chord has distance of 8 meters. We're good. From the center of the circle, we're good. There's the center. That's the length right out there to the chord, 8 meters, all right? We took the radius. We made 17 happen here. We're looking for this missing piece. We have 15. Now, that's not the whole stretch here, my friends. That's a little tick mark stretch. So that's half of the chord. It's half of the chord. So this side over here is also worth 15. Now, well, it's really kind of hard to tell in there right there with that 15, and this is a 15 and a 15. What do we have for the chord? The chord will equal 30 in its meters, okay? So there you go, a really good challenging problem of the day here for midweek.